In this video, we're going to do a couple of things. We are going to talk about linear regression. First off, we'll talk about diagnostic, the R-squared value, and then we'll work on the example. So I'm going to actually start kind of with the example, but we're not going to work through it yet. Here's a little problem put together. This is actually based on real data pulled from the source is the U.S. Statistical Abstract, and that basically deals with the cruise industry. And here we're looking at the number of passenger and crew, or the revenue earned from passengers and crew members in billions of dollars as a function of the number of cruise ships sailing. So here we have the number of ships, and here we have the passenger and crew. And overall, you kind of look at it, you see as the ships are increasing over time, and the passenger and crew revenue is also increasing. So we're going to find a linear regression equation that models the data. Okay, so what we will do is we'll enter our data. Remember, that's in stat edit. L1, L2, I've already got it inputted here. My number of ships will go for the X's. My passenger and crew revenues will go on the Y's. And so now I will go over here and produce my regression. So I'll go to stat, calc. I want to do option 4, linear regression. I'll hit enter. And now it's going to give me a set of information. So, of course, we have our slope and our vertical intercept. So we can actually write those down. We can say our equation would be, well, let's call we'll call R the revenue. And remember, this is measured in billions of dollars. Measurements are important. And then we have the number of ships, which I'll just call S. So a number of ships. So I'm not using X and Y. I'm going to say to calculate the revenue as a function of the number of ships, my equation would be A, 0.03, I'll just round it, times X, which in this case is the number of ships, minus 1.3. I'll just round it to the tenths place. Now we have this R. We're going to ignore the R value. R squared in this case, the diagnostic, would be 0.6 or 0.63. Now the R squared is really what we're going to talk about first. The R squared is a measure of goodness of fit. So this will tell us basically how well our line is going to fit our data. Now I like to think of the R squared as a percentage. So R squared can not be any smaller than 1 or 0, so it can be 0 all the way up to 1. So it can be anywhere between 0 and 1. So if you're at 0, this is a terrible fit. Think about this as a test grade. This is like a percentage. So if you get a 0.5, that's equivalent to a 50%. Not very good, right? So what are good R-squared ranges? Well, generally depending on the discipline, but 0.5 to 0.7 is decent. 0.7 to 0.9 is very good. Think about this as your grade. 70% to 90% can be a very good range, and 90 to 100 is awesome. So I'll just describe it that way, but just note that it varies from discipline to discipline. So we've got our equation. R squared, R of S equals 0.03 S minus 1.3. Okay, now we're going to go into our Y equals. We're going to clear out what's already in there. We want to make sure our plot 1 is on, so go up to plot 1 and make sure you hit enter so you get the black box over it. We want to get the equation in, so to get the equation in, we'll go to stat. We'll go over to we want to go over to VARS, not stat. VARS, option 5, statistics, over to EQ, and select Reg EQ, and there it puts it in for us. It rounds farther than we're going to round, but it's still 0.03 X plus or minus 1.3. It just does plus the negative. Okay, so now we should be able to, we're going to go to zoom so we can see the whole image. And we're going to actually do a special zoom on here called zoom stat. And what that will do is it'll ensure that our data points are displayed. So there you have it. Number of ships along the input axis, the revenues generated along the vertical axis. Now you might say, well, it kind of bounces up and down. But the trend, or the pattern is that as the number of ships increase, the output, the revenue increases as well. So we're going to run with that. We're going to say this is a pretty decent fit. I mean, the R squared isn't that great. It's 0.63, but we're going to go with it. So this is okay, not very great.